Hello again, everyone. I hope that you're all doing all right, especially since the weather's getting nicer. Once again, this is Stuart Mitchell. I'm a graduate math student at Wayne State University. I work with Professor Oakes, and I will continue right along with Lecture 3, where we will discuss adding and subtracting signed numbers and variables. In this case, it's just going to be adding and subtracting a bunch of signed numbers because the rules with variables work the same way. Okay, so a few helpful things to go over just before we start with the examples. So I guess we can call these some, oh, apparently it does not want to draw. Some helpful rules that we can apply. One of those is minus a negative equals plus a positive. So minus a negative equals plus a positive. So in general, if we're talking about, I guess, just in general with variables, with any numbers, if you had x minus negative y, you're essentially multiplying a negative 1 to this negative here as well. So when you do that, we know that two negatives multiplied together equals a positive. So we can simplify this to x plus y. That works for any two numbers you have. That would, that can help you out because you don't have to look at the double negative. Because, even in English, when we're speaking, double negatives aren't really like helpful. I mean, yeah, they kind of work, but they don't convey what we're trying to do as clearly as we'd like them to. So we want to get rid of it when we can. So that's a helpful rule to help clear that up when you're looking at adding and when you're looking at combining signed numbers with addition and subtraction. In a similar regard, you can think of if you plus a negative is the same thing as minus a positive. So if we have, say, x plus negative y instead of minus negative y, if you don't like seeing the two symbols next to each other, you're essentially thinking, like, you can always put a negative, or when you're thinking about a negative number, you can always think of it like a negative 1 is being multiplied to its positive counterpart. And in this case, when we multiply positive 1 times negative 1, we get negative 1 overall. So this could simplify back down to x minus y, which sometimes is helpful to think about too, because it's a little confusing when you're looking and you see two operation symbols right next to each other. It's not very helpful. So the more you can condense, the more it can help you out, like, overall. One more thing just to kind of keep in mind and I'll keep these rules up over here as we go through these examples because it's not going to require that much writing, is to know that, which I'm sure you've heard the notion before I talked about, addition is commutative. Sorry, this pen does not like me. I promise my writing is normally better than this. It's a little difficult to write with this stylus on my computer. This screen's just a bit fidgety at times. Okay, but addition is commutative, and what I mean by that is this is saying x plus y, whether these numbers are positive or negative, which we'll go over up there too, is the same as y plus x. So you can switch them around sometimes. That can be especially helpful if you have something like negative x plus y, because sometimes it's not really great. Like, if this number is smaller than this one especially, it's kind of weird to think about the negative first. You could change this to, say, y minus x. And that works because we carried the negative sign around with it. Because if we had, just to kind of, illustrate my point too, you had, and also just to tell you to err on the side of caution when you're doing this, you can keep this in your back pocket, but like if it's confusing to you, you don't have to necessarily do it. But if you had, say, x minus y, we can apply the rule that we said up above in reverse, because this would be x plus negative y. That's the same thing, which would, if we commuted the two of them, that would be negative y plus x, if you wanted to think about it that way. So just be careful. If you see a subtraction sign in the middle, you can still commute them, but you have to kind of undo what we did before, where you condense it. You have to think about it like two separate signs. You're adding a negative number to this positive number. So if you wanted to switch them, commute them, you'd have to carry the negative sign along with it. So just, be careful if you choose to do that, because if not, you could end up with the wrong answer. And, I want to see you all succeed, so I don't want that to happen. Okay, so let's go through these examples, keeping in mind the rules that we just went over. And a new color, of course, because that always makes things fun. In this one, you don't necessarily have to like switch them because they're both negative. However, we can think of this where the plus and negative, because this one would go mostly towards this rule, plus a negative equals minus a positive, where we'd have negative 2 minus 12. This is the same. These are equivalent expressions. Which, if you think like, you're subtracting 12 from negative 2, if you count backwards that'd be negative 14. Sorry, let me rewrite that, because that was not very nicely written for you. It doesn't look like a number. It looks kind of just like I messed up. There we go, negative 14. Or if you wanted to think about it a different way, you could think of this also equaling, because addition is commutative, as negative 12 plus negative 2, which equals negative 12 minus 2, which is, again, equal to negative 14. Either way you want to think about it, it'll work just the same for either way. It's just whatever you prefer. But I definitely think it's helpful to think about it where you do whatever you can to get rid of the double operation in between the numbers, because that can be kind of confusing. That is kind of confusing for everyone. Like, it's not a great thing to have. This one we don't really have to change, but we could apply the rule number 3 to this one if we choose, but I'll do it normally first. If you just added straight through with this one, negative 9 plus 10, well, we know negative 9 plus 9 is equal to 0, and then we have 1 left over, so this just equals 1. If we applied rule 3 to this one, we could switch them around, if that helps you think about it, around the addition sign, and then we'd have 10 plus negative 9, which we know plus a negative equals minus a positive, which would then be 10 minus 9, which equals 1 as well. This one is a little bit less work, but this one, I guess, you could think it might be a little bit easier. So whatever way works for you, I'll always try moving forward. Sometimes it might not always be possible, either just because there's not more than one way to do something, or just it might be a lack of my own knowledge in that, because sometimes I've only ever learned one way to do something. But I'll always try my hardest to do things more than one way, because sometimes it makes sense to people if you do it a different way. And I always try to look at it from all angles to help people as much as possible. Anyway, moving on from that, here we can apply, sorry, I have to scroll back up, rule number 1 to this one that we called rule number 1, because we have a minus, a negative, which it can be really confusing to think about. When you're saying like minus a negative, like you're subtracting a negative number, like you're not going to want to continue to go in the negative direction. You want to actually go in the positive direction, because you're reversing the negative. Like that's I guess like a way to kind of think about it or justify it in your mind. But this we can change with that rule to 23 plus 23, which we know is equal to 46. And that is the end of that one. That's a nice you know, a nice good demonstration for rule one with some concrete numbers, but it works in any case. This one you can do in two different ways too. It depends on how you want to think about it. If you do 4 minus 16, here you can just think like, you know, 4 minus 4 equals 0, and then you still have to go 12 in the negative direction. So this would equal negative 12. You could think about it if you wanted to undo rule number 2. This could be thought of as 4 plus negative 16, if that helps you think about it more, like you're adding a negative number to it. Or if you wanted to switch it from this and use rule number 3 as well, you could think about this as negative 16 plus 4 and then count up from negative 16, if that helps you think about it better. It just helps if you want to apply rule number 3 when you start off with a minus sign and a minus symbol in between two numbers. It can help to think about undoing rule number 2 first, because this is the same thing as saying minus a positive is the same thing as plus a negative. If you add the negative, it can help you see like how you'd have to commute them and keep that negative sign where it needs to be. Because you can't, you know, negative 16 plus 4 is not the same thing as 16 minus 4. So you have to keep that in mind if you choose to do it this way. But in this case, it might make it easier to see, okay, negative 16 plus 4, you have to count up from negative 16 instead of, you know, think backwards from 4. So this is, you know, this will still give you the negative 12. Okay, moving right along. This one applies quite a few different rules here. Or like it's a nice kind of application of all of them. Like here we can start off with rule number 1, the minus a negative is plus a positive, because we have minus a negative in the middle. So this is gonna, if we apply rule number 1, we're gonna have negative 23 plus 23. If you can see this here, that's great. If you also want to, we can apply rule number 3, the addition is commutative, and say that this is equal to 23 minus 23, in both of which case, either way you want to look at it, we're going to end up with 0. Because if you count up 23 from negative 23, you're going to end up at 0. If you count down from 23 to count down 23 from positive 23, you're going to end up at 0 too. Either way, it helps you to see it. It's great. You're going to end up with the same thing. It really is just a personal preference. So that'll help you out there. Now, in number 6, they really want to trip you up because there's 3 in the middle, but it's the same type of idea, except we're applying some, in this one, let me get a different color for this one. In this one, we're going to have to apply some order of operations as well, because we have, as much as it doesn't look like it here, if you expanded on this is like saying in brackets, negative 1 times, oops, sorry, I want to try to make a dot. We're going to, negative 1 times negative 2. So we have to think about order of operations first. In this case, multiplication comes first anyway. Remember PEMDAS. Or please excuse my dear Aunt Sally. Parentheses is first, then exponents, then multiplication, division, addition, subtraction. In this case, we have parentheses and multiplication, so we have to take care of this before we talk about, before we deal with the subtraction here. So thinking about that, moving along from that, just be mindful, if you come across something like this, you have to do order of operations first, because when you see just a subtraction sign outside of here, that's multiplication. It's the same general logic as this too. Like I explained, when you have minus a negative, you could think about this like multiplication, like you're having x plus negative 1 times a negative number. So you'd end up with a positive in there. And it's like you have to think about it as multiplication and handle that first. But especially now, because we're in parentheses, we have to deal with that first. So if we take care of what's in parentheses, we're going to be left with -5 minus, and then -1 times -2 is a +2. So we're going to have in that parentheses -5 minus 2, which is equal to, you can drop the parentheses now, -5 minus 2. Either way you think about this, like if you wanted to change it with, add the negative and then switch, commute it to see it differently, like this could be switched to -5 plus -2. You could switch that around, however it helps you to see it. And either way you want to look at it, you're going to end up with -7. So either way, it'll work that way. Just be mindful if you see something like this where you have three operations in a row, try to like work from the inside out like we did here. We took care of the inside, like the innermost part first, the one that was in parentheses, the minus a -2, because we have negative, negative, -2. That's what we're saying when we say -2 is -1 times -2, which we know is +2, which we saw right here. Simplify it as much as possible first, and then worry about the operation that is initially in the middle of both numbers, which was still a minus sign. And then either way you want to think about it, you'll get to -7. But you want to try to simplify it down as much as possible first to avoid confusion. All right, that concludes lecture 3. I hope that was helpful. Thank you, and stay safe. I'll talk to you next time.